Okay, so yesterday we started in lesson 2.4. We started talking about imaginary numbers, right? And the idea behind the imaginary numbers is that I is equal to the square root of -1 and I squared is -1. Okay, so up until yesterday, if you were asked to take the square root of, say, -16 up there, you had to say I couldn't do it. There's no real solution there. Now, we can do it with the use of I, our imaginary unit. So I represents the square root of -1. With that, remember that I squared is equal to -1. So when you square the square root of -1, you get -1. Okay, so for those of you who missed yesterday, of course, you'll have to get caught up on, and some of you will pick up on as we go through, but we simplified square roots, negative square roots, which means we basically already separated out -1 that represents as I. We added and subtracted complex numbers. We just added and subtracted like terms. I is not a variable, but you can kind of think of it as a variable. And then we finished the day with multiplying. Okay? We distributed. We FOILed. And we added like terms. Now the catch was here, we didn't ever leave an I squared in an answer, did we? I squareds always became -1s. And we're going to work with some of the same stuff today as we divide. So the very last example here, we multiplied conjugates. And they're conjugates because they have the same pieces, but they have opposite signs there. Okay, so complex conjugates, because we're talking about complex numbers, but are complex numbers with the same real parts, opposite imaginary parts. So that middle sign changes. And the nice part about them is when you multiply them, you always get a real number. The i's will cancel out there. And we're going to use that today because we're going to divide complex numbers now. And when we divide complex numbers, notice what it says here. We're going to multiply the top and bottom of the fraction by the conjugate of the denominator. So here's the deal. When you're giving a simplified answer with fractions, you can't leave a square root in the fraction. That's something you learned back in Algebra 1. Well, I is like a square root. We can't leave that in the denominator. And so we're going to have to do some work to get rid of it. As we look at this first example here, it's 10 over 2 minus I. Well, I can't do 10 divided by 2 because I'd also have to do 10 divided by I, and I can't do that. Okay? But we need to get rid of this I in the denominator. So your process today is going to be multiplying by conjugate of the denominator. So what's my denominator right now? It is 2 minus I. What's the conjugate of 2 minus I going to be? 2 plus I. If you multiply the denominator by 2 plus I, guess what? We multiply the numerator by 2 plus I. Okay? Remember, what we do to the denominator, we always do to the numerator. Because as long as you're doing the same, you're not changing the values, just multiplying by 1. And we're going to do the math here for it. In the numerator, how do I multiply 10 times 2 plus I? We're going to take 10 and we're going to distribute. 10 times 2 is 20 plus, what's 10 times I? 10i. Okay. Denominator. How do I multiply 2 minus I and 2 plus I? What are we doing here? FOIL, distribute, FOIL, whichever one you want to say. So 2 times 2 is 4. 2 times positive I is 2i. And then Negative I times 2 minus 2I minus I times I minus I squared. Okay. From here, we're doing any cleanup we can. In this particular problem, the cleanup is going to happen in the denominator. What kind of cleanup do you see? What do we see?
You can combine your 2I.
Okay. Yeah. 2I minus 2I?
0, 0.
They cancel out, right? If these are conjugates we're multiplying, my middle terms will always cancel out. So those are gone. What about minus I squared? What is I squared? Negative 1. So this really becomes minus negative 1. What's minus negative 1? Plus 1. And what are we adding that to?
4.
4. Okay, so let's rewrite what we have. My numerator is still, excuse me, 20 plus 10i. My denominator, we have the 4 minus negative 1. 4 plus 1, which is 5. Am I done? Or does this simplify more?
Simplify. Yeah, 4, 2.
Okay, and here's the deal. If this denominator 5 can divide into all pieces in the numerator, we can go another step. Now, it has to be able to divide into both pieces, not just one, but both pieces. So, in this case, 20 divided by 5 is
4.
4 plus 10i divided by 5?
2.
2i. Then we have 4 plus 2i. They won't always clean up quite that neatly, but that one did. Okay, questions there about what we did? We're really taking a lot of the multiplying skills. Those of you that missed yesterday, you're seeing a lot of what we did yesterday with multiplying and adding and subtracting like terms. Okay? Okay, B. 4 minus 3i over negative 1 plus 2i. Realize, right now they're subtracting on the top, adding on the bottom. There's no cleanup I can do right now. Okay, I can't do any canceling or reducing when I have terms being added or subtracted. But we know we can't have that I in the denominator. What do I do to get rid of the I in the denominator? What am I going to multiply by?
Negative 1 here.
Okay, yes, thank you. Negative 1 minus 2i. I want you guys to do some responding here. Make sure you're following along. That's an easy question. Notice he kept the real part and the imaginary part just made opposite. So if it's negative 1 minus 2i, we're multiplying by negative 1 minus 2i on top. Okay? How do we multiply our numerators this time? We're going to FOIL, aren't we? If you prefer to think distribute, that's fine. I'm going to start with 4. 4 times negative 1? Negative 4. 4 times minus 2i? Minus 8i. Negative 3i times negative 1? Plus 3i. Negative 3i times negative 2i. Plus 6i squared. Okay. Same deal with the denominator. Negative 1 times negative 1. positive 1. Negative 1 times negative 2i. Plus 2i. 2i times negative 1. Minus 2i. 2i times negative 2i. Minus 4i squared. Do you see some cleanup that can be done? I say the answer better be yes, or we're in trouble. What kind of cleanup do we see? Okay. 2i minus 2i is going to cancel. Those are going to be gone. Minus 4i squared. Well, remember, this I squared is a negative 1. So it's negative 4 times negative 1, which is really just going to become a plus 4. What about this plus 6i squared up here? It's 6 times negative 1, which is really just going to become a minus 6, right? You can get in that habit of, oh, minus 4i squared, that's plus 4. Plus 6i squared, that's minus 6. Okay, let's see what we have here. On top, what like terms can we clean up here? Negative 4 goes with what? Negative 6. What's negative 4 minus 6? Negative 10. Minus 8i plus 3i. Minus 5i. Denominator. 1. And plus 4 is going to be 5. Okay. Can I clean this up farther? Yeah, because I have a single 5 in the denominator, and that can divide into both pieces. So negative 10 divided by 5 is negative 2 minus 5i divided by 5 minus 1i or minus I. Okay. Remember, just like yesterday, we're leaving our answers in the form a plus bi. C should be very similar. Now, I do want to go through C as practice. Hopefully you guys can stay a step ahead of me. But then also I want to talk about how to express our answer in C, because it's not going to clean up quite as nicely as our last one did. Okay. C is 5 minus 2i over 3 plus 4i. What are you doing? Okay, good. Conjugate of the denominator, so we're multiplying by 3 minus 4i. And again, we are multiplying, distributing, FOILing, getting lots of practice there, right? 5 times 3. 15. 5 times minus 4i. Minus 20i. I'm going to use my negative 2i. Negative 2i times 3. Minus 6i. Negative 2i times negative 4i. Plus 8i squared. Denominator. 3 times 3 is 9. 3 times minus 4i is minus 12i. Then distribute my 4i. 4i times 3 plus 12i. 4i times negative 4i. Negative 16i squared. Okay. Is there some cleanup you see? It's kind of a silly question at this point. There definitely is, right? What do we know? Plus 8i squared is going to be minus 8, right? Because that I squared is negative 1. What about minus 16i squared? What's that going to be? Plus 16, because again, that I squared is negative 1. And in the denominator, do my middles cancel as they're supposed to? Yeah. If you multiply by the conjugate and you get to the end and your middle doesn't cancel in the denominator, you've made a mistake somewhere. Okay? So that's something to always to look for. Negative 12i plus 12i cancels. Okay, where are we at? What do we have? What do we have on top, guys? 15 and minus 8 is going to give me what? 7? What about my i's when I put my i's together? Negative 20i minus 6i is going to be negative 26i. What's my denominator? 9 plus 16, 25. Yep, thank you. What's different about this one? Yeah, 25 doesn't go into 7, and it doesn't go into 26. Now, to officially make it in that a plus bi form, we're still going to go ahead and break it apart into two pieces and put the 25 under both as both denominators. So I'm actually going to write this as 7 over 25 minus 26. I'm trying to think which way I write it. 26 over 25 and then times I. You can do this one of two ways. I tend to write it there where the I is like the variable next to it. Your I can either be next to your fraction or in your numerator. It cannot be in your denominator though, just like if it was a variable. And if you have any like that that don't clean up very nice on homework, I'm not really sure what Savas wants, so. Okay, D is kind of getting lost here, but we do still have a D to go through. Thoughts on D? As in, what do you mean? Divide everything by 3? Well, and we could divide 12i by 3i, but can we divide 9 by 3i? I mean, we'd end up with I to the negative 1, which we really don't do negative exponents with i's. I mean, we could talk about the possibility of dividing everything by 3. I wasn't going to really go that direction. You could divide everything by 3 and simplify that way, but we'd still have a step to do here. In that, I still have an I in the denominator, don't I? So normally we say multiply by the conjugate. And there's a couple different ways we can do this one. What would you call the conjugate of 3i? What if you think of that as 0 plus 3i? What could be a conjugate there? Zero plus 3i, the conjugate would be 0 minus 3i. So one option would be we could multiply by negative 3i. Now I debate, do I want to take you that way, or do we want to make it even a little bit easier? What is it that really matters here? We just need to get rid of the I, yes? So the other option is that we could just multiply by I, because we're not going to be foiling here to where it's going to cancel out. Okay? If we multiply by just I, it'll make the math a little bit easier. We'll just have less to simplify. Now, could you multiply by negative 3i? Yeah, that'll get you there too. So I would use either one of those, either negative 3i or I. You could do positive 3i for that matter as well. The key is we just need that I to cancel out. The conjugates, when it's two terms, does that. Here, I'm just going to suggest we multiply by I. As I said, negative 3i, positive 3i, or I, or negative I would all work. Now, if I multiply by I, realize on top we're just distributing, yes. I times 9 is 9i. I times 12i. 12i squared. On bottom, what's 3i times I? Three I squared. Okay. Go through and clean everything up. What do we know about I squareds? I squareds are negative 1. So look at what happens if we make those negative 1s. 9i is still 9i. What does plus 12i squared become? 12 times negative 1 is going to be minus 12. 3i squared. 3 times negative 1 makes it negative 3. And can we clean this up now? Yeah, we can divide that. Both pieces divide by 3. More specifically, I guess, negative 3 here. 9i divided by negative 3 is going to be 9 divided by negative 3 is negative 3, and then the I. What's minus 12 divided by negative 3? Plus 4. To put it in our complex form of A plus BI, I would reverse it and say 4 minus 3i. Okay. I mentioned yesterday, I don't know if Savas is going to get nitpicky if you put negative 3i plus 4. If you don't put the I term first or second. Complex form is typically A plus BI. So the real part, then the imaginary part. So Savas could get picky. They might be nice about it. I'd like to think they'd be nice about it, but you never know. Okay, somehow or another, did you end up with that answer? You could have taken a different route. Maybe some of you did and got there, right? That's perfectly fine. Okay, we've got one more thing to do, and that is solve equations. Okay. I'm not sure, have we done this year? I'm trying to think if we've solved, I don't think we've really solved a lot of square root equations this year, but we've talked about, I think. If not, you've seen it in the past. X squared equals negative 16. If you have x squared equal to a number, how do we solve and get x? What is it? What do we do here? If it's x squared, we're going to take the square root, right? So our job in this section is get your x squared by itself. This one's already by itself. Once x squared is by itself, we're going to take the Square root. Now, what's the square root of x squared? X. What's the square root of negative 16? 4i? What? Ooh, plus or minus. So a couple of different things here. First of all, when we take the square root in an equation setting, what do we always need to throw in front of the square root? A plus or minus. And then here, remember yesterday, we talked about the square root of negative 16. The square root of negative 1 is I. The square root of 16 is 4. And so this is going to be plus or minus 4i. So you're going to have to put that plus or minus sign in front of your answers there. Okay? And that's when you take the square root in an equation setting. If they just give you a radical sign, say, what's the square root? You just give what they want. But if you take the square root in an equation setting, we have to account for positive and negative. Now, B, 4x squared equals negative 36. What should I do first? And you wouldn't have to here, but it'd be advisable. Is the x squared by itself? No. How can I get x squared by itself? If it's 4 times x squared, we can divide both sides by 4. So then I'm going to have the equation x squared equals negative 9. How do I solve if it's x squared equals negative 9? We're going to take the square root. Once you get the x squared by itself, take the square root. Square root of x squared is x. What's the square root of negative 9? Okay. Plus or minus. The square root of 9 is 3. The square root of the negative is I. So plus or minus 3i, because we're doing square root of negative 1 times square root of 9. Okay? C. What's got to be my first step here?
Subtract the 75.
Okay, isolate that x squared. In order to isolate the x squared, we want to subtract 75. When we subtract that, x squared equals negative 75. Now the x squared by itself, we're going to take the square root, yes? Okay. What's the square root of x squared? X. Square root of negative 75.
Decimal.
But we're not doing decimals in this lesson.
You're right, we're doing odds.
Okay.
So square root of negative 75i.
Not exactly. This relates to something you missed yesterday, so. Now, I do agree, when we take the square root, we are going to have to say plus or minus, right? Now, okay, plus or minus square root of negative 75, but what do we know about negative 75? Oops. There is a negative 1 there, yes? I'm going to write the pieces out of this one. What else do we know about 75? If you've got 75 cents in your pocket, what do you likely have? 3/4. Why are 3/4 important here?
Times
25 is a
square.
perfect square. So we talked yesterday about breaking up perfect. If there is a perfect square within there, you need to pull it out. There's a perfect square within 75. We need to pull that factor out. Okay, so now we've got plus or minus. The square root of 25 is 5. The square root of negative 1 is I. The square root of 3, still the square root of 3. So that answer would be plus or minus 5i square root of 3. Okay? And that simplifying perfect squares like that, or non-perfect squares in this case, we did work on that on the front page. Okay? Okay, last one. What are my steps to getting an x squared by itself?
Get subtract.
Okay? We're going to subtract the 25. So now I have 9x squared equals negative 25. Is x squared by itself? What do we do to continue getting x squared by itself? Divide by 9. So now I have x squared is, what is negative 25 divided by 9?
Decimal.
Okay,
It's 2 something.
so I'm going to go with negative 25 ninths. You could go the decimal route if you wanted to, but I'm going to go this route. Okay, because this route I'm not having to pick up my calculator.
You're slapping around.
Well, okay, so if it's x squared equals, we're going to take the square root. When I take this square root, first of all, we're taking the square root in an equation setting, so what do you need to make sure you put in front of your answer?
Plus or minus.
Plus or minus. What do you know about the square root of 25?
Equals 5. Oh,
It's 5.
3. Negative 5.
What do you know about the square root of 9?
3.
It's 3. What do you know about the square root of that negative?
It's a negative.
It's I.
Yeah.
So what am I going to say here?
It's 5 over 3.
Plus or minus 5/3 I. I don't know that you'll see any fractions like that in homework, but every time I throw a fraction at you, I get all this, oh gosh, I don't know what to do with a fraction. This is tough. Grab a calculator, but this one's, not impossible there. You could have done a decimal as well, but I just did this. Okay, lesson 2.4 is out there and available, and it should be listed as due tomorrow.
Yeah.
So make sure you get that done. Okay?
Yes.
It is like 20 or 22 questions. However,
They're so easy.
some of them go very, very quickly. Okay? So,
I'm already on question 15.